Now we're getting exciting. Chapter 4.5 is about adding and subtracting fractions that do not have the same denominator. This is the meat. This is the big meat of this chapter. LCD means the same thing as LCM. Least common denominator or least common multiple. Least common denominator. But the key here is you look at the biggest denominator or a number bigger. Okay? Now, method 1 for finding the least common denominator or least common multiple of 6 and 8. Alright, I'm going to list 6 and I'm going to list 8. The multiples of 6, well, 1 times 6 is 6, 2 times 6 is 12, 3 times 6 is 18, 4 times 6 is 24, 5 times 6 is 30, 6 times 6 is 36, 7 times 6 is 42, 8 times 6 is 48, and yada yada yada. Now I'm going to write my multiples of 8. They are 8, 16, 24, 32, 40, 48, yada yada yada. Notice they both have 24 in common. They both have 48 in common, and if we kept going, they would have 60 and 96, I believe it, or 94. They would have a bunch of other numbers that are in common. So, even though it says least, you're really looking at the biggest number or a number that's a little bit bigger than them. Okay? So 24 is quite a bit bigger than 8. Alright? So 24 happens to be their least common denominator. Method 2 deals with using prime factorization. Okay? If I look at 6 and I look at 8, I know that both of them have a 2 in common. And then 2 times 3 gives us 6, and 2 times 4 gives us 8. Our 2 is repeated. So I just bring it down one time. Now I could split the 4 down smaller, but 3 and 4 have no factors in common except 1. So all I do is, now I brought that common factor down, and then I bring my 3 and I bring my 4 over here, and I multiply them. 2 times 3 is 6, times 4 gives us 24. This is more thinking, this is more work. Now, with 7 and 14, the first thing I'm going to do is look at my biggest number. Can I take 14 divided by 7 and get a nice answer? Yeah, I can. So, our answer here is 14. I look at my biggest number here, 20 divided by 12. That's an ugly answer. So, I'm going to actually take 20, okay, and I'm going to take 12. 20 and 12 have 4 in common. Alright, 4 times what gets me 20? 5. And 4 times what gets me 12? Times 3. These are repeated. So our LCD is 4 times 3 times 5. So I really did my factor tree like I did here. I just set it up a little differently. So now 12 times 5 gives us 60. Now, with 72 and 60, I know that 12 goes into both of those. So 72 and 60, let's use our calculator. That might help us a little bit. 72 divided by 12 gives us, oops, there you go. Now you can see it. Gives us a 6. So 12 times 6. And then 60 divided by 12 gives us 5. So 12 times 5. These are repeated. I bring it down one time. So 12 times 6 times 5. So I'm going to cheat. Times 6 times 12 gives us 360. Ew. Would you want to multiply factors of 72 until you got to 360? That would stink. Now with 15 and 18, and I tend to put the bigger number on top. I know that 3 goes into 18 6 times, 3 goes into 15 5 times. Here's our repeated factor, so 3 times and 6 times 5. So 3 times 6 times 5 gives us 90. Now, these are some ugly problems, and if you didn't get it, make sure to ask. And before we get into actually adding and subtracting fractions with unlike denominators, we need to review building equivalent fractions. 1/3 with the denominator of 9. So I want to build this fraction up so that it has a denominator of 9. What do I do to 3 to make it a 9? Well, I multiply by 3. And if I multiply the bottom by 3, I multiply the top by 3. So 1/3 is the same thing as 3/9. Now, the fraction 2, notice I called it a fraction because the whole number is a fraction over 1 with the denominator of 7. Well, 1 times what gets me 7? Yeah, 7. So I multiply the top by 7. So 2 times 7 gives us 14 on the top. Now, in your book on page 260, there's an illustration that illustrates how to add unlike fractions physically. Make sure to look at it on your own. So, steps to adding unlike fractions. Find LCD, build equivalent fractions, then add or subtract like fractions. So on number A, we have 2/5 plus 4/15. So what I need to do is decide what my LCD here is. And I do this a little different than anybody else. So catch how I'm doing my steps. Our LCD here happens to be 15 because 15 divided by 5 is a nice answer. Now, 5 times what gets me 15? You're right, times 3. And if I multiply the bottom by 3, I multiply the top by 3. So this becomes a 6. And I put plus, and by the way, put your LCD here on the bottom. 15 is already a 15, so all I do is bring that plus 4 down there. Then 6 plus 4 is 10 over 15, and remember I can divide out a 5 because our unspoken rule of fractions is you have to reduce it. And my answer becomes 2/3. Now, 15 and 10. Ooh. Well, think of your multiples of 10, or again you can come over here and 15 is 5 times 3 and 10 is 5 times 2. These are repeated, so 5 times 2 times 3. So that's 10 times 3 gives us 30. Alright, so our LCD happens to be 30. Bring one big fat fraction bar over and put your denominator, your LCD, in the bottom. Now, 15 times what gets me 30? Times 2. And notice I can't use my x for multiply because now I've got a variable in there. So 2x's times 2 gives me 4x's, and there's a minus. 10 times what gets me 30? Yep, times 3. And 3x times 3 is 9x. Do both of these in the top have x's? Yep. That means they are like terms, so I can combine them. And 4 minus 9 is negative 5, and we just tack the x along and divide by 30. 5 goes into 5 once and into 36 times, so that leaves us negative x, or negative 1x, over 6. If you're not okay with this, ask questions. Evaluate x minus y, for x being 7/18 and y is negative 2/9. So we say 7 over 18 minus a negative 2 over 9. Remember, leave it, change it, so that becomes plus a plus. Now, our LCD happens to be given to us. It's in the problem. It's 18. So bring one big fat fraction bar over and put your LCD on the bottom. And now we've got 7 plus 2. So 7 plus 2 is 9 over 18. And 9 goes into 9 once and into 18 twice. So we're left with 1/2. Now, which one's larger, 3/4 or 9/11? I could build equivalent fractions like this, but why? Because there's a shortcut. Remember we used cross multiply to see if they were equal? Well, we can use that same trick now, and you have to do it this direction, from bottom right to top left. So 11 times 3 is 33, and then bottom left to top right. 4 times 9 is 36. 36 is bigger than 33, so it just so happens that 9 over 13 is bigger than 3 over 4. So that one is bigger. Now we don't actually go over chapter 4.6, but I want to introduce this to you. This is called a complex fraction, and a complex fraction is either a fraction divided by a fraction, or it can be, a combination of fractions and numbers or mixed numbers divided by, a fraction, or even mixed numbers, or even an improper fraction. But the nice thing about it is it's just like dividing fractions. So we use the rule, leave it, change it. We use it vertically this time. So it would become x over 4, and I could just go ahead and change that divide sign to a times and then flip this fraction over. Now 2 goes into 2 once and into 4 twice. And then x times 1 is x, and 2 times 3 is 6. Now, this ugly mess, there's an even bigger shortcut. And I didn't learn this until Cal 1. Find your LCD of all three denominators. And remember, a whole number is a fraction over 1. So the LCD of 5, 1, and 10 happens to be 10. Now, what I'm going to do is I'm going to multiply all three numerators by the LCD. Minus 2 times 10, every bit over 3 times 10 over 10. And again, this is over 1. Okay. Well, 5 goes into 10 2 times. That leaves me a 2y minus, nothing cleans up other than just saying 2 times 10, which is 20, over, and 10 divided by 10 goes away, leaving 1 times 3, which is 3. And since this has a y and this doesn't, QIYD. And instead of a bunch of little fractions, we only have one big fraction now. And if you need that information and you don't get it, ask later.